Hello everyone. I hope my mic's a better quality than I had in class today. Sorry, I had some of my inputs mixed up. Um, but I just wanted to add a footnote in here, just a little extra something, because there are a lot of questions on some certain topics in class that I'll talk about later, that weren't really made clear, and also we didn't get as far as I would like to have gotten. So think of this as a supplement over the week. Um, I might make these so that we can play a bit of catch up so we can get to where we want to be at the end. Or just to make these so to add some extra info that I might not have had time to cover in class. So a big question and a problem in the homework that I saw, for the ones that I've graded about five of them now, is that uh, people are getting mixed up between strings and ints. So when you initialize an int variable, the I in int isn't capitalized. But if you initialize a string variable, the S in strings is. So why is that the case? Well, in reality, there are actually two data types in Java. We didn't touch on this, but types of variables are split into two categories, basically. There are primitives and non-primitive data types. So there are two categories. Primitives are the most basic types of variables in Java that you will encounter. Um, These are like the baseline building blocks, and they have no other functions attached to them other than the basic plus, minus, equals, 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 um, greater than, less than operations that you have that we'll talk about maybe next class. They don't have any like dot equals functions that I know a student came up to me with in their homework. They don't have any of the extra flares like dot add or like dot increment or whatever may be. They have no other functions other than the basic plus minus times multiply. Even they might not divide. They might even have those in the case of like booleans or something like that. Equals equals and equals to. Uh, on the other hand, there are non-primitive data types, and these things have, frankly, a wide bevy of different operations you can perform on them. You could, we'll touch on that later. Um, so there are 8 primitive data types in Java. The int, byte, short, long, float, double, boolean, and char. These four right here, int, byte, short, long, really are the same thing. Uh, they all represent numbers, but to a different degree. So byte is a 8-bit number, which means it can store from negative 127 to 128. The next largest would be short, which can store, I think, between somewhere around negative 32,000 to positive 32,000. Integer can store more than that, and long can store the most. So these four are the same, although we use int because, well, it's the easiest to type out, for one, and also it's less memory intensive than for something like long. If you're storing like a two-digit variable in in a long format, then you're using up a bunch of extra memory space with like what? I think it's more than double the size from a long to an int. And you're just not using the extra space because you're storing a two-digit number, right? So uh, we wouldn't really want that. That wouldn't be ideal. So yeah, we just use int as a default. If you really wanted to like min-max your code for efficiency, you could use like a byte or a short. Although that's usually the performance gain is so small that compared to the time that you put in, that it really wouldn't be worth your time, honestly. Floats and doubles are both they're both numbers with decimal places, basically. Uh, float is just the default baseline, and double I think is larger than float. Um, these aren't very accurate. Computers tend to get numbers in decimal places wrong. Um, Although I haven't really encountered the problem with personally because I've never really delved that deep with those things, and usually it's negligible. Um, but be careful of that because computers work on a base 2 system. So if you have like, let's say, for a short, you'll have something like 8 bits, and each bit will have a either 0 or 1 value. So the first bit, it goes right to left, by the way. The first bit, uh, just imagine like we have 8 bits right here. The first bit represents the ones digit. Second bit represents twos. third represents fours, fourth represents eights, fifth represents 16th, sixth represents 64th, and seven represents 128, I think. Or no, sorry, 16, 32, 64, 128. And then the eighth bit will be positive or negative. So if it's like 0 would be positive, 1 would be negative. So you have, if you have like a 1, 1, 1, 0, 0, 0, 0, 0, for example, that would be a 1, a 2, and a 4, which would be 7, 0, 0, 0, which would be, or 0, 0, 0, 0, which means that 8, 16, 32, and 64 are off limits. And then the last bit would be a 0. So that means that it would be positive. So you'd have positive 7. Um, the thing is, this doesn't really translate to decimals. You could have, like, let's say, let's just pull up a new tab, actually. Let's say you have 0, 0, 0, 0, 0, 0, 0, 0. Let's say you have 8 bits, right? 1, 2, 3, 4, 5, 6, 7, 8. Point, and then we'll have another 8. 1, 2, 3, 4, 5, 6, 7, 8. So how would we write, like, 1.5 per se? Well, we could have something like, this is half, this is a fourth, this is an eighth, a 16th, 32nd, 64th, 128th, and 256th, right? Or we could have this, yeah. We could have like that, and this would be also the positive negative. Well, what if we want to write it half? Well, that's easy. We have that. And this would obviously not be here, the point, because that can be represented in binary. You just have something like this, and the computer would know, okay, halfway through, we'd have a decimal place. But we're putting it in there just to, you know, for clarity's sake. Okay, half is pretty easy. How about a fourth? Fourth is pretty easy as well. This is a fourth place value, right? Okay, that's fine. How about 3/4? Okay, well, you have this. A half and a fourth is 3/4. Same with 7/8, and so on and so forth. But what if we wanted to write something like a third? Well, a third is less than a half, so we don't want that. A third is less than a fourth, or it's greater than a fourth, so we'll grab this. But we're still not there yet, because a third minus a fourth leaves a bit left over. It leaves a sixth left over. Okay, well, how do we represent a sixth? Well, a sixth is larger than an eighth. So we take this. Well, now, okay, an eighth, a sixth minus an eighth is a 12th. So how do we represent a 12th? We have a 12th left over. Okay, well, a 12th is less than, per se, let's see, a 12th is less than, we have halves, fourths, eighths, 16th. Okay, so 12th is greater than 16th, right? So now I put a 1 here, but 12th minus 16th is, you have a bit left over. So you'll never actually get to the place value you want. You'll just run out of memory because it'll just keep going 1, 1, 1, 1, 1, 1. Try to approximate. It'll get lower. Each of these values get smaller and smaller. You'd have half, fourth, eighth, 16th, 32nd, 64th, 128th, 1 over 256, 1 over 512, 1 over 1024, and you keep going, but you'll never actually get to a third, which is a bit peculiar. So what your computer does is it says, okay, well, we have 8 digits right here, and they're all ones. You know, it's not really beneficial for me to add another one. So we have 0, 1, 1, 1, 1, 1, 1, 1, 1. That should be 8. Yeah, okay, that's 8, hopefully. That says, okay, we have 8 digits here. We have 8 digits for the positive. We have 2 bytes, right? Which is 8 digits. A grouping of 8 digits is called a byte. And, you know, this float format can't support more than 2 bytes. So we're just going to cap it off here. So you're not actually getting a third. But your computer can approximate. So whenever you'll see like running around, if you're dealing with decimals, you'll actually see like some sort of irregularities with, you know, how decimal places are represented. So yeah, there are other formats that are accurate. For example, you could have it so that each of these values is actually an int. So you could have like an int, and then 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 an int. Or you could have even if you wanted to make it more efficient, you could have a byte here, a byte here, because each of these are just 8 bits. But if you notice, that means it's 8 times larger than, well, what it was originally happened. So these can get pretty big pretty quickly. And the issue arises is because you're trying to translate a base 10 decimal system into a base 2 decimal system. Our base 10 decimal system, we have 1 over 3. We could have, we operate in base 10, right? Because we go, this place value right here is a 1s. Oops. This place value here, we have the 10s and then a 1s. This place value here, we have hundreds, 10s, 1s, and then thousands, hundreds, 10s, 1s. But in binary, we have here ones, twos, fours, eights, 16s. Um, so once you get to decimals, it can't actually like add up to a third because you can't represent a third in binary uh, from a base 10 system. So yeah, that's just a little tidbit. Uh, yeah, okay, so the next two, back on track. Boolean, which we also touched on in class, this is just storing true or false. It is also, I think, the smallest of any of these because it is just one bit, right? It's 0 or 1. 0 is false, 1 is true. And char is a character, a single character, which is pretty important. From the ASCII system. So if we search up like ASCII, this is the ASCII table. Uh, that's pretty outdated. Here we go. So yeah, it's I think 8 bytes, and it represents every single, character that you have, right? So you have null, SQH. Okay, I don't know what these mean. You have like tab, all the signs, all the letters, all the lowercase letters, and then parentheses, punctuation, delete even, semicolons greater than. You can have like escape represented in there. Um, null just means nothing. Null means nothing, quite literally. Um, so yeah, you'll notice that string isn't here either, right? It's just these 8. There's no string here. That's because string is actually a non-primitive variable. Non-primitives are also called classes. Uh, and when you make a non-primitive variable, you call that an object. Uh, these are things that we'll touch on later. Um, so yeah, some of the non-primitives that Java includes by default are strings, arrays, array list, hash maps, and dates. So a string is actually, let's talk about an array first. An array is basically just a collection of variables. Any type of variable, it can even be non-primitive. And you'll have it in a list, and we'll dedicate a class to this afterwards. But you basically just have it in like a big block, a set of any single type of variable. If you want to have a set of ints, go ahead. You can now make each item in the array a different value. These are things that we'll dive into deeper with the theory behind it and how you're going to manipulate them. But a string is just a collection of characters, of chars. That's how you get the string, right? So then you type out the string, and then it'll compile that into just a bunch of characters all stacked together. And so that's why string is capitalized and primitives are lowercased, because when you write a class, you always capitalize everything, right? So you capitalize, well, I should say the start of every word, actually. Whereas primitives, they're all lowercase. So the primitives will be lowercase. Everything else will have the first letter capitalized, like this, like array list. That's just syntax. That's just how Java programmers like to keep things organized. If you see, capitalized first word, that means it's an object. If you see lowercase, that's a primitive. If classes do ring a bell, though keyword classes, that is because we made one in class actually today, or I showed you guys how to make one. So recall back to when we were at the end of class, we were setting up this whole thing, and I right-clicked this and I created a new Java class. Well, this is the same thing. This Java class is the same thing as this thing right here that I'm referencing. Oops. We actually made a class right here. This public class AYLUS CS, and then we typed in the main method. A thing about Java is it follows a philosophy in programming called object-oriented programming. If you recall, objects are just the manifestation of classes, which it sounds a bit weird now, but we'll talk about it later. have plus has served plus this dot year served. We can do something like this where we come over here, we set AYLUS member, and we also dot set years served. It's served for 1 years, so we'll do that. And we can run it. Oh, it has served 1 plus, oops, I'm on the outside of the parentheses, plus years to finish up the sentence, because it looks a bit weird right now. There we go. Look at that. So this variable, quote unquote, stores a string and an int, and we have operations here to set them, and we also have an operation to print it out. So we've just made our own pseudo variable. We'll delve more in depth into this, but this is just a little taste test of what you can do with classes in Java. All right, well, I'll be signing off now. I think this has gone long enough, and I've kind of overstepped my bounds of what I should be revealing. Uh, this, but yeah, have a nice night, guys. I'll see you soon.